Hello, this message is from anti-proton.com, that's me, Tom, anti-protons if you like, to Sakuramane. First off, let me say I applaud what you're doing, trying to check your child's surroundings and yours as well while living in Japan. I would if I lived in Japan. I will be in Japan this April, most likely, on deployment of what I'm currently doing right at this moment. I have some equipment I have to put out there and do some stuff. I'll be in southern Japan, but regardless, I'll see if I can go north and get some samples. I wanted to help you a little bit with your Geiger counter. Tell you a couple basic things that might help you. I'll spare you a course in physics because I don't think that that's what you need. I think what you need to know is whether or not looking at the number in your Geiger counter like you see right this moment is cause for alarm. First, let me state the Geiger counter that you have is not the right type for picking up surface contamination, like food contamination, for example. It's not going to be sensitive enough. It needs something like one of these in the front, although one that's much bigger. The Geiger counter I'm going to get tomorrow will have this. But regardless, it is basically powerful enough to give you a basic idea of what's going on around you, whether or not you have anything radioactive around you, to a degree. The units that you're using, you see that has the little USV in front of it? That means microsieverts. And that's not really the right unit to use when measuring, detecting radiation that you're unaware of the origin of. I mean, if you know exactly what it is and you're calibrated for it, whatever. But it's not really wrong because you can still get an idea. If the numbers looks like this normally and then it goes up all of a sudden, then you have an idea that you're all of a sudden around radiation. I mean, you can still kind of get a good feel using microsieverts, and most little small Geiger counter devices have a tendency to want to use this measurement anyway. I usually try to use counts per minute if I can. But regardless, let's use microsieverts because that's what you have. 0 microsieverts all the way up to 0.4, 0.5 is not all in all too dangerous. It's not going to kill you over time. What is more important is to see the change. If you live in Denver, Colorado, 0.5 might be perfectly normal for you, whereas where I live, 0.14 is approximately what you normally see. I'm a little bit below that right this moment, but you get the point. The reason it fluctuates, by the way, is because the Geiger counter can't give you a complete 1 minute average, or in this case an hour's average, based on a few seconds of readings. It can't. It can't tell you exactly how many detections it's had in a minute because it hasn't run for a minute yet. Think of a lemonade stand. You start a lemonade stand. You start selling lemonade. In the first 10 minutes you make X number of sales. You can calculate what you think if you keep at that same rate. You could calculate how many how much lemonade sales you're going to make in the rest of that hour. Now, if every 10 minutes you recheck your math, you'll find that that your math will fluctuate as lemonade sales fluctuate. You get the idea from an analogy? So that's the reason the Geiger counter is going 20 and 4, then 18, then 32, blah, 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 blah. That's why it's doing that, because it's kind of averaging. Once it gets done with the entire average, the whole sum of all the calculations it's made, it can give you a total final average, which is that final number that you see. You're going to pick up a number. There will be radiation. There's always radiation. It comes from space mostly. Now you're in Japan, so some of it could be coming from Fukushima. It's possible. Realistically speaking, most of the radiation you're picking up on that Geiger counter is not coming from Fukushima, because that's a perfectly normal series of readings you're getting. The fluctuations between driving in the car and then when you're sitting out there in the playground area, that could be explainable by ground and rock. Here's a piece of here's an example. Here's a piece of granite countertop. And granite countertop, I know it's a countertop, but it is still granite. Granite is all around us, and granite does have more radiation in it than other things. Well, not all granite, but some granite. This one doesn't have very much, but it has a little bit. Enough to make it tick a bit. And as you can see, my readings go up. Depending on what the ground is where you were standing with your child, depending on what's going on around there, that can make a big difference as to the radiation levels that you pick up. Not getting much off of this today. In a 1 hour average, I get about 19 excuse me, I'm thinking it counts per minute, which is what I normally use. You'd get 0.19 microsieverts per hour. But anyway, now let me give you an idea of what something more dangerous would be. For the example, let's start out with this. Here's a piece of uranium glass. This glass actually contains uranium. Still safe enough for me to hold. I should make a note at this point. The danger is not so much the radiation where you all are running around and playing. The danger is really the radiation that you ingest into your bodies. The radiation that you eat. Breathing, yes, but generally most of it doesn't float around too much in the air, not after the event, after the water's washed it away. It does to some degree. But mostly it comes from eating it and drinking it. And it's very hard to test the food. It's better this is where we have to have a little bit of faith in the governments or not. If you have absolutely no faith in the government, like apparently most people on YouTube, which is fine because they blunder enough to not deserve our faith, I guess. But if you have no faith in them whatsoever, then I'm not sure what to tell you. We all know the Japanese government has done a pretty good job of trying to sweep a lot of this under the covers. But if you consult your local environmental protections agency, they might actually tell you how much radiation they're detecting, and they'll give it to you in becquerels, which is decays per second. And then what they'll do is they'll say, I expect that I will find no more than 1,000 becquerels per kilogram, meaning decays per second of radiation per kilogram of material for whatever the certain substance is. And then they should show you the readings that they're getting. The problem is that without really, really advanced equipment, it's hard to really detect that. Because like this is a piece of potassium chloride salt. It doesn't really put a... I should probably do this upside down so I don't contaminate my unit. It doesn't really show off very much at all, even though it has a pretty good amount of radioactivity in it. I guess it does a little. Very difficult to pick up with a device like this. Impossible to pick up with a device... Well, not impossible. Very hard to pick up with the unit you have. Like, for example, I have a sample of tritium right here. This is tritium. Radioactive tritium. The real damn deal. It glows in the dark. I mean, you see it glowing, maybe? Here it is. And it's only readable at a really, really close range. It glows in the dark. Now, let me show you something really, really powerful. This is the reading that you want to run away from. For getting food contamination, if you ever see something like this occur, this is when to run away. Where is it? There we go. Let me get close enough to this thing. I have it pretty well shielded up in here. That would be what's called dangerous. In case you're curious, this is a alpha-emitting radioactive compass. As long as it's sealed inside of this bag, it's not dangerous to me because I can't inhale it or eat it. I could actually hold it in my hand quite safely. The second that I inhale it or eat it, that is when it becomes dangerous to me. Notice I'm already at a full 1.2 microsieverts per hour, 1.3, and steadily climbing. This will go all the way up to 10, by the way, very easily. Anyhow, so I guess what I'm trying to say is your Geiger counter is useful, and it will give you an idea where places are more radioactive. Both the cesium and strontium, the two most deadly things that you see around you, are easily detectable in great quantities, but the small quantities, the ones that get in your food and your liquids, you're not going to be able to detect them with that Geiger counter. I'd still keep it though. As you see, I have a Geiger counter, so obviously I believe having a Geiger counter is safe, or not safe, useful, even if you're not detecting stuff like uranium glass, for example, or tritium. But regardless of that fact, Please ask me if you have any questions. I'd be happy as a clam to help you with understanding your Geiger counter. It looks like a beta and gamma detecting Geiger counter. That's the reason the numbers, by the way, float up and down, though. The reason the numbers float up is because they're averaging. See how mine's averaging? Mine averages slower than yours does. Yours is averaging almost every second. Mine is averaging every, what, 5 seconds, I think I have it set to. I can change it to be more uppity, downity, but whatever. Alright, in fact, yeah, I'm not going to mess with that right now. But, so there you go. That's a little bit of information on the Geiger counter. If you have more questions, let me know, and I'll be happy as a clam to explain it all. This is Tom from anti-proton.com, and I applaud you checking with your Geiger counter and getting a bearing on what's going on in your reality. Because let me tell you something, when I come to Japan, I'm going to have my Geiger counters with me too. So, bye-bye.